Continuing on with our 6.2 lesson, we're looking at general probabilities and trees. We've already looked over the trees a little bit. We're just going over our probability calculations. So this is when we add probabilities. This occurs when we say something like or. So when we are adding probabilities, the most important observation that needs to be made is whether or not the events are mutually exclusive. If the events cannot happen at the same time, then they are mutually exclusive. If the events are not mutually exclusive, which means they are inclusive, then your formula will be slightly different. So, if two events A and B are mutually exclusive, then for a probability A or B, it's just the probability of A plus the probability of B. So for example, if we're rolling a dice and we wanted to know the probability of getting a 2 or a 3, well, you can't get both a 2 and a 3 at the same time, so you would just add the probability of getting a 2 with the probability of getting a 3, and that would be the probability of getting a 2 or 3 in one roll. Makes sense? Probability of inclusive events, though. So let's say it was probability of getting a multiple of 3 or an odd number. Now, those aren't mutually exclusive because 3 is both a multiple of 3 and it is an odd number. So because there's at least one spot where there's something that is counted twice, it happens in both of those, you just have to subtract that off. So probability of getting a multiple of 3 plus probability of getting odd minus whenever they both occur. So minus that probability of getting a 3. I'll show you what this looks like in some of our examples then. First, we need to decide if they're mutually exclusive or not. So if a bag contains 35 eggs, 15 of them are yellow, 10 of them are blue, and 10 of them are red, and 10 of them are blue. What is the probability of selecting a yellow or a red egg? Now, if you reach your hand into the bag and just grab out one egg, can it be both yellow and red? Well, no, it cannot. So yes, these would be considered mutually exclusive. Okay, these cannot happen together. Yes, they are mutually exclusive. Exclusive means they're excluding each other. A pair of dice is rolled. The two numbers are added with the probability the sum is either 5 or a 7. Now, if I roll two dice and get like a 1 and a 6, now if I add those together, can that sum be both 5 and a 7 at the same time? No, there can really only be one sum. So yes, these two things are mutually exclusive. Okay, you can't get both of them happening at the same time. What is the probability of drawing a red card or an ace from a standard deck of cards? Now, is it possible to have an ace that is a red card? Yes, it is. There are two of them. There's the ace of hearts and the ace of diamonds. So no, these things are not mutually exclusive. If we wanted to find the probability, we'd have to find the probability of a red card or probability of an ace, or should I say and, we'd have to find the probability of a red ace. We would add these two and then subtract the probability of a red ace, because that would be counted twice in a sense. A bowl has 20 wheat crackers, 20 sesame crackers, and 14 rye crisps. If a person picks a cracker at random, what is the probability of picking either a sesame cracker or a rye crisp? Now, if you put your hand into the bowl and you grab out a cracker, could one cracker be two of the same thing? No, it cannot, so these are mutually exclusive. These are totally separate from one another. 3 cards are selected from a standard deck of 52 cards. What's the probability of selecting a king, a queen, or a red card? Now, king and queen, those are going to be exclusive of each other. You can't grab a card that is both a king and a queen. But this has, in a sense, kind of two different, or in a sense, 3 different or statements. King or a queen, king or a red, queen or a red, because all 3 of these events are put in here. Now, you can get a red card that is a king, you can get a red card that is a queen, which means that these 3 events together will not be mutually exclusive. Okay, there is a possibility of overlap on these ones. A pair of dice is rolled. What's the probability the sum is an odd number or a multiple of 3? No, these are not mutually exclusive. We already talked about that. If you rolled 2 die and you wanted them to add up to something, if they added up to 1, that would be odd. If they added up to 5, that would be odd. If they added up to 7, that would be odd, and so on. If they added up to 3, that would be a multiple of 3. 6 would be a multiple of 3. 9 would be a multiple of 3. Are any of those numbers going to be the same? Yes. 3 and 9 are both multiples of 3, and they are odd. So no, these are not mutually exclusive. Adding mutually exclusive events together, we just simply add the two probabilities. So for example, to choose an afternoon activity, summer campers pull slips of paper out of a hat. Today there are 25 slips for a nature walk, 35 slips for swimming, and 30 slips for arts and crafts. What's the probability that a camper will pull a slip for a nature walk or for swimming? So one or the other. Now, these are mutually exclusive events because you can't pull one that says both of them on there, and there are 90 slips total. So, the probability of getting nature walk or swimming equals the probability of nature walk plus probability of swimming. Probability of nature walk was 25 out of 90. Probability of swimming was 35 out of 90. So when we add these together, we would get 60 out of 90, which reduces to 2/3. So the probability of a camper pulling out a slip and getting either a nature walk or swimming is 2/3. Adding mutually inclusive events. So these are events where it's possible that they could both happen at the same time. There is overlap. So again, first we would add the two probabilities, then we would subtract the both probability. So what's the probability of drawing a face card or a black card from a standard deck of cards? These two events are inclusive since a card can be both a face card and a black card. So the probability of getting a face card or a black card is probability of face card plus probability of a black card minus the probability of specifically a black face card. So, probability of a face card, there are 3 out of every 13. So there'd be 3/13 possibility of getting a face card. Probability of getting a black card, well, half the cards are black, half the cards are red, so that probability would be 1/2. Now the probability of getting a black face card, okay, there would be 6 out of the total 52. They just reduced it to 3 out of 26, okay, because there'd be Jack, Queen, King in clubs and in spades. So that's why we'd say there's 6 out of 52, which is 3 out of 26. So if we add these up, or add these two, should I say, and then subtract this one, we would get 8 out of 13, which is about 0.62. So you can call it either the fraction 8/13, or you can call it 0.62 as your probability of drawing either a face card or a black card. So let's look at some examples of our own. We're going to look at all of those events that we described as either being mutually exclusive or not, and we're actually going to find those probabilities. So if a bag contains 35 eggs, 15 of them yellow, 10 of them red, and 10 of them blue, what's the probability of selecting yellow or a red? Well, yellow was 15 out of 35, red was 10 out of 35, so we add those up and we get 25 out of 35, which reduces to 5 out of 7. We have a 5/7 chance of getting yellow or red. B, a pair of dice is rolled and the two numbers are added. What's the probability that the sum is either 5 or a 7? Well, there's 4 different ways to add up to a 5. You can get a 1 and a 4, a 2 and a 3 and a 2, or a 4 and a 1. So there's 4 different ways that they would add up to 5. There are 6 different ways that they'd add up to 7. 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. So that's 6 different possible ways to add up to 7. How many different ways are there to roll 2 dice? Well, I would use the fundamental counting principle. 6 different ways on one dice, 6 different ways on the other. 6 times 6 is 36. So we would say ways to add up to 5, 4 out of 36, ways to add up to 7, 6 out of 36. So in total then, if we wanted either the 5 or the 7, we would add those up and get 10 out of 36, which reduces to 5 out of 18. We have a 5/18 chance of getting either a 5 or a 7. What is the probability of drawing a red card or an ace from a standard deck of cards? Well, there are 26 out of 52 red cards. There are 4 out of 52 ace cards, but 2 of those double up. There are 2 red aces, so we have to get rid of those extra 2 there. So 26 out of 52 plus 4 out of 52 minus 2 out of 52 becomes 28 out of 52, which reduces to 7/13. We have a 7/13 chance of getting either a red or an ace out of the standard deck. A bowl has 20 wheat crackers, 16 sesame crackers, and 14 rye crisps. If a person picks a cracker at random, what's the probability of picking either sesame or rye? Well, probability of getting sesame is 16 out of 50. There are 50 crackers total, and there are 16 of them as sesame. There are 14 rye crisps, so 14 out of 50. So 16 out of 50 plus 14 out of 50 is 30 out of 50, which reduces to 3/5. We have a 3/5 chance of getting either sesame or rye. 3 cards are chosen, selected at random from a standard deck of 52 cards. What's the probability of selecting a king, a queen, or a red card? So, probability of selecting a king, there are 4 kings out of 52. Selecting queen, there would be 4 queens out of 52. Probability of selecting a red card, there are 26 out of 52 red cards. Now we have to start kind of getting rid of any things that we're doubling up on. Now we only double up on 2 things. There's no way to double up on kings and queens. There is a way to double up on red queens and red kings. There are 2 red kings, so we have to take out 2 of those out of 52. There are also 2 red queens, so we have to take out another 2. So this is what we would get. This is how we'd add up our probabilities of drawing either a king, a queen, or a red card. When we add all this up and subtract these ones off, we get 30 out of 52, which reduces to 15 out of 26. So we have 15 out of 26 chance of getting a king, a queen, or a red card. Example F, a pair of dice is rolled. What's the probability that the sum is odd or a multiple of 3? So I wrote on the side here, these are all the possible ways we can add up to something. If we get 1 and 1, that would add up to 2. If we get 1 and 2, or 2 and 1, that would add up to 3. So there are 1 ways for 2, 2 ways for 3, 3 ways for 4, and so on. Oops. So here are all of our possibilities. At the end, I wrote that there are 36 possible ways to roll 2 dice. So if we want the probability that the sum is odd or a multiple of 3, well, probability that it's odd would be 3, 5, 7, 9, and 11. So we have to add those possible ways. 2 plus 4 is 6, plus 6 is 12, plus 4 is 16, plus 2 is 18. So odd numbers is 18 out of 36. For multiples of 3, that would be 3, 6, 9, and 12. So we just add those up. 2 plus 5 is 7, plus 4 is 11, plus 12 is 12. So we have 12 out of 36 here. We also have to subtract off the ones that are both odds and multiples of 3. That happens here for 3 and 9. So 2 plus 4 is 6. There's 6 ways out of 36 for it to be both an odd number and a multiple of 3. So we add these two and subtract this one, and we get 24 out of 36, which reduces to 2/3. We have 2/3 chance that the sum of our 2 dice will be odd or a multiple of 3. Venn diagrams. Venn diagrams can help show whether events are mutually exclusive or not. In the Venn diagram below, events A and B are not mutually exclusive because there is an overlap. Anytime there's an overlap, that means these can both possibly happen at the same time. Now this area over here, we call it only A, or you can call it not B, because it's only the stuff that happens for event A. This area is called A and B. It's where both of them occur together. This area, we call this only B, or we call it not A. So when using these Venn diagrams, the Venn diagram at right shows the number of juniors on varsity sports team at Elwood High School. Some athletes are on varsity teams for only 1 season, some for 2 seasons, and some for all 3 seasons. If a varsity athlete is chosen at random from the junior class, what is the probability that he or she plays a fall or a winter sport? So we would count the total. If we add up all these numbers in here, we would find that there are 32 athletes in total. Now we need to count up just the fall and the winter. Now, right, because it just says fall or winter, we would just add up all of these in the 2 circles. So 8, 4, 5, 3, 1, and 5. Okay, we make sure to hit all of these numbers because these are the ones that are in all of the fall, all of the winter. We're just including everything. The only thing we exclude is this number that's only spring. Now because this number, the 4, the 5, and the 1, happen to be still in the fall and the winter circle, we also include those ones, even though those people were also in spring. So when we add all of those up in total, we would get 26. So the probability that we pick an athlete at random and they happen to be in a sport in either the fall or in the winter would be 26 out of 32, which we can reduce to 13 out of 16. For our next example, 40 senior citizens were surveyed about their music preferences. The results are displayed in the Venn diagram. If a senior citizen from the survey is selected at random, what is the probability that he or she likes only country and western music? Well, we know there are 40 total, so we don't have to count them up. Country and western only would just be this 6 right here. So for only country and western, we would say 6 out of 40, which reduces to 3 out of 20. So that would be for only country and western. Now, the question goes on to say, what is the probability that he or she likes classical and, should I say, and or, so either one, country, but not 1940s pop? So, because it says this and or, we would include everything possible. So 3, 7, 6, 4, 6, 5, we're including all of those. But because it says, but not 1940s pop, we don't want to include anything that is in the 1940s pop circle. So we're not including 9. We're going to get rid of the 5, rid of the 6, and rid of the 4, because those ones were part of the 1940s pop, and they said, but not that amount. So to do that then, all we're doing is adding 3, 7, and 6. That would add up to 16 out of 40 people, which reduces to 2 out of 5. So 2/5 would be our probability. And that'll wrap it up for our 6.2 lesson.